France, November 1944. The rain hadn't ceased for 3 days. Mist lay thick across the Moselle Valley, muffling the clatter of engines. The front had bogged down, mud so deep it swallowed a jeep's wheels. On a ridge overlooking a stone bridge, one American howitzer crew kept working. Their gun was a 150-yard Thiel 50-yard M1 Long Tom manned by 6 men, its barrel crusted in soot. The objective was simple: the bridge at Sanavo, the last crossing before retreating German armor could regroup. The trouble was, they couldn't strike it. The Germans were across the river, engineers already rigging the bridge for demolition. Every second mattered. Kessler, the gunner, checked his sights again, murmuring under his breath. He'd been computing angles for 15 minutes. His sergeant, numb from the cold and impatient, barked, "Orders are clear!" "We aren't wasting rounds," command radioed. "Hold fire." Kessler didn't reply. His thumb traced the ridges of the fuse casing. A T5 variable time fuse. Standard issue, but constrained by doctrine. Officially, it was for airburst only, detonating by radar proximity at a preset altitude. Ground impact detonation was forbidden. The danger: the shell might explode in flight or inside the tube. But Kessler knew something the manual didn't. A week earlier, he'd seen a round misfire and burst just above a target and noted the timing anomaly. The radar sensor tripped early when humidity was high, scattering its signal off fog instead of the ground. He'd been thinking about that ever since. Now the fog was dense, heavy with moisture. Perfect. He called to his loader. "Bring me a VT fuse and a time ring." The others looked up. "You can't arm a proximity with a time ring," one said. "That's not in the table." Kessler said nothing. He began tweaking the dials. 0 delay. 1/10 turn back. A setting that technically shouldn't exist. The 0 delay twist. An old artillery rumor. A hybrid fuse trick combining time and impact modes. The gambit: set the VT radar to trigger late, but leave the contact detonator open. The result was a round that sensed surface reflection, penetrated briefly, then detonated inside the target instead of above it. It was the difference between a flash and a fracture. He ranged the bridge at 3,400 meters. Wind negligible. Humidity 91%. He exhaled and did the math in his head. Elevation 16 degree. 2 bags of propellant. Muzzle velocity 853 ms. Time to impact 9.3 seconds. The loader hesitated. "You're not firing that," Kessler answered flatly. "We're out of time." The firing pin fell. The Long Tom recoiled, the barrel plunging into smoke. The shell screamed through the fog, unseen and unheard, then vanished into the gray. The men waited, breath held, counting. 9, 10, 11. A white flash bloomed beneath the bridge, not above. A sound like folded steel rolled up the valley. When the smoke cleared, the bridge was gone. A hole in the landscape where stone had stood. No one spoke. The crew only stared. "Range error," the loader murmured. Kessler shook his head. "No calculation." Minutes later, their radio crackled. Higher command furious, demanding who authorized that shot. No one answered. Because in the fog and mud of Sanavo, one gunner had just broken every regulation in the book and achieved what the Army deemed physically impossible. A single unauthorized fuse setting had just erased a bridge that bombers couldn't hit for 3 days. In doing so, Kessler crossed a line from which no soldier could safely return. The instant when disobedience becomes genius. In 1944, the U.S. Army Field Artillery was an empire of rules. Every trajectory, every charge, every fuse setting was prescribed, measured, and memorized. The system allowed no improvisation. You didn't think. You executed. Artillery was called the king of battle, but the throne was built on paperwork. Soldiers lived by TM 9 to 1901. The Artillery Bible, a 400-page manual of angles, propellant charges, and fuse codes. Deviate once and you weren't a hero. You were a liability. The reason was simple. Artillery was math, not art. Each fuse type, PD, point detonating, VT, variable time, MT, mechanical time, had exact specifications. PD detonated on contact, ideal for soft targets but useless against concrete. MT exploded after a preset delay, great for airbursts over troops, but susceptible to humidity. VT, radar-based, T5 or T9, was meant to detonate above ground targets, not on impact. On paper, these systems worked perfectly. In the mud of France, they did not. Fog, moisture, and uneven terrain upset calculations. Even a 1-degree error in elevation could shift impact by 100 yards. Proximity fuses, new to the battlefield, were designed to detect reflections from hard objects, tanks, bunkers, trees. In bad weather, they read moisture as metal, making them hazardous. In heavy fog, they sometimes detonated prematurely, even inside the gun tube. A shell exploding in the barrel didn't merely wreck the weapon, it vaporized the crew. After a dozen catastrophic in-barrel detonations during 1943 testing, Ordnance Command banned VT fuses for ground targets. Airburst only. That was the rule. Anyone caught modifying or combining fuses risked court-martial. But the ban left a gap. Bridges, fortifications, and river crossings, targets needing precise delayed detonation, couldn't be hit effectively by airbursts or point detonators. Shells either burst too soon or glanced harmlessly off concrete. That's where men like Sergeant Walter Kessler began experimenting. He wasn't an engineer. He was a farm kid from Ohio who understood machinery by feel. To him, a fuse wasn't sacred. It was a clock, and clocks could be tuned. In his field notes found decades later, one line stands out. The fuse doesn't know it's illegal. It only knows time and pressure. That summed up the tension between regulation and survival. The Army wanted predictability. The battlefield demanded adaptation. By late 1944, veterans whispered of unofficial settings, tiny twists that delayed detonation just long enough for shells to burrow into hard targets. It was never written down or taught, only passed as half-jokes and rumors. "You want to kill bridges?" one sergeant told a rookie. "Learn the half-turn trick, but don't tell the brass." Most laughed it off as too risky, until someone proved it worked. When Kessler's round erased that span, his battery did not cheer. They froze. In the artillery world, success did not shield you from punishment. Innovation was confessed, not rewarded. That single shot exposed the paradox of American warfare, a system built for order that depended on men willing to break it. Manuals began perfect, then the battlefield rewrote them. In France, the mud and fog rewrote them in a single blast. The Army labeled Kessler reckless. History would judge him right. Sometimes the line between myth and miracle is one person refusing to follow the book. Artillery isn't chaos. It's geometry with a pulse. Every explosion starts with an equation. Time, distance, pressure, and fuse, delay deciding who lives and who dies. The U.S. Army's M1 155 Long Tom was the backbone of that math. It could hurl a 95 lb shell nearly 15 miles, but accuracy depended on the fuse, the brain of the projectile. In 1944, there were three principal fuse types every gunner knew well: M48 point detonating, PD, M54 mechanical time, MT, and variable time VT, T5 or T9. Each had limits. In France, none performed perfectly. Moisture, fog, and low clouds skewed radar-based fuses. The tiny vacuum tube inside a VT fuse pulsing at 100 mm could mistake raindrops for solid returns. A shell might detonate 100 feet early, or not at all. Mechanical time fuses, with their spring-driven escapements, jammed in mud. So when the Army ordered VT for airburst only, it wasn't mere caution. It was survival. But Kessler wasn't thinking of doctrine. He was thinking of timing. In clear air, a round traveling at 853 Embratrias would reach 3,400 meters in about 3.99 seconds. In fog, increased air density slows the projectile just enough to change the fuse's radar delay by fractions of a second. Tiny differences matter. A 0.02-second shift at 8:53 a.m. SS equals roughly 17 meters, enough to move a detonation from a harmless airburst to a direct bridge strike. That was Kessler's exploit. By twisting the time ring back a tenth of a turn, he introduced a delay between radar trigger and explosion. The shell ignored the first reflection and waited for a stronger return. And the rest followed. The reflection from stone, not fog. It was field physics done under fire, and it worked. The zero delay twist setting wasn't in any manual. It wasn't safe, but it was sound. What made it revolutionary was how simple it was. The fuse was still a VT, it was just layered to. The radar thought it was still waiting for its target when the contact detonator hit, producing a simultaneous surface burst that behaved like a precision demolition charge. In technical terms, Kessler had created a hybrid dual-trigger mode. Radar confirmation followed by instantaneous ground detonation. The pressure wave doubled, forming a shaped blast that crushed the bridge structure inward instead of outward. No one designed the fuse for that. But the physics didn't care. And that's the point. In war, technology doesn't evolve in laboratories. It evolves in mud under pressure by men who trust intuition over instruction. The U.S. Army's bureaucracy called Kessler's fuse tampering. Engineers years later would call it the missing variable because the math of artillery isn't just about range and elevation. It's about timing so precise it borders on instinct. In that moment on the ridge, surrounded by fog and fire, Kessler turned math into defiance. He wasn't breaking rules. He was finishing an equation the manuals hadn't solved yet. And in one impossible shot, he proved what no staff officer wanted to admit. That war isn't won by perfection. War isn't won by perfection. It's won by correction. The fuse that made Kessler's miracle possible was also the most feared piece of ordnance in the U.S. arsenal. The VT proximity fuse, known officially as the T5E1, was a technological marvel wrapped in danger. It worked by emitting short radio pulses through a tiny oscillator tube in the shell's nose. When those pulses bounced off a nearby object and returned stronger, the fuse triggered detonation. In 1944, this was alien science. A vacuum tube the size of a thumb surviving the shock of being fired at 25,000 car of acceleration. It was also unstable. In the summer of 1943, the U.S. Ordnance Department tested 8,000 VT fuses at Aberdeen Proving Ground. 12 shells exploded inside the barrels, detonated less than 100 yards from the guns. 3 crews were killed outright. The findings were written in bold. VTUs on surface targets prohibited, authorized for air detonation only. The Army listened. Every field manual repeated the warning. A premature VT detonation wasn't a misfire. It was suicide. That's why, by regulation, every fuse had to be inspected and set by the book. Delay setting, factory calibrated to 0.03 seconds. Safety limit, no manual modification permitted. Minimum airburst, 70 FAT, but on the battlefield, those numbers didn't mean safety. They meant limitation. Airbursts were devastating to infantry, but worthless against stone, steel, or water. The concussion dissipated before it reached the structure. The bridge at Sandoval had already survived 12 Allied air sorties and 100 conventional artillery shells. Physics, not firepower, was protecting it. Kessler understood that. He knew that IFA 155-meter shell traveling at 853 meters could detonate after impact even a few milliseconds later. The energy would transfer directly into the bridge's load-bearing arch. One well-placed round could destroy what entire air wings couldn't. But that idea terrified ordnance officers. The fuse delay window was microscopic. Between 0.01 and our 0.003 seconds. Too short and the shell exploded in the barrel. Too long, and it buried itself harmlessly. There was no safe zone. Still, soldiers whispered about a secret field mod. Twist the timing ring 1 mark backward, tricking the proximity sensor into thinking it was still searching while the contact detonator armed. Officially, it didn't exist. Unofficially, it traveled through every battery in France. The army called it Aramor. The men called it insurance. By the numbers, it made sense. A properly fired 150 mm shell carried about 15.6 lb of TNT equivalent, generating 1.4 million psi of pressure at the point of impact. Detonating that fractionally inside a bridge span multiplied the structural load failure by a factor of 3. For engineers, that was math. For gunners, it was a miracle waiting to happen. And Kessler wasn't the first to think about it. British gunners in Italy had experimented with similar delay shims, but none dared report it. Too risky, too unofficial. Until one American gunner decided that risk was just another variable in an equation. The truth is, the Army didn't ban Kessler's trick because it didn't work. They banned it because it worked too well, unpredictably, dangerously. Without supervision, the proximity fuse represented the future of warfare, electronic precision, but the people using it still lived in a mechanical age. The military wanted control. The fuse wanted autonomy. Kessler's shot proved that the technology had already outgrown its rules. One forbidden twist of metal had exposed the gap between invention and obedience. And in that gap, an entire bridge vanished. That's why the numbers mattered. They weren't statistics. They were warning labels on progress itself. And like most warnings in war, they were written in hindsight. Sannevo, Lorraine, November 15, 1944. The 379th Field Artillery Battalion had been pounding the same valley for 3 days. Fog rolled off the Moselle like smoke, swallowing the horizon. At the bottom of that valley stood a single stone bridge, 40 minutes long, 2 arches built in 1889. German supply trucks still moved across it like ghosts. Command wanted it gone. Airstrikes failed. Rain grounded the thunderbolts. The bridge stood untouched, protected by fog and luck. That morning, the order from headquarters was blunt. Hold fire until visual contact is confirmed. But at Battery C's gun pit, Sergeant Walter Kessler wasn't listening. He had spent the night recalculating. Temperature 41 point air density, 1.22 kilos per cubic meter. Muzzle velocity at that humidity would drop by 4%. That meant the shell would land short unless he increased elevation by half a degree. He adjusted the sight manually. 16.5-degree propellant charge, 2 bags fuse. VT band mode. He took out Asmol screwdriver and twisted the time ring back 1 notch. It was no longer proximity, no longer contact, something in between to his crew. It looked like insanity. AM. The assistant gunner said, "Bridge is invisible in fog." No target confirmation. Kessler wiped his hands on his jacket. "I don't need to see it," he said of the math can. He checked the fuse again. Radar arm delay. 0.05 seconds. Impact trigger open. The sensor would think it was still in flight when it struck the bridge. A fractional delay measured in thousandth of a second. Fire. The 155 roared. The recoil crushed the spades into mud. The shell vanished into the fog, leaving only the echo of its velocity. 9 seconds later, a flash bloomed low. Not in the air, but under the fog line. A sound followed like a thunderclap wrapped in iron. Then, nothing. Silence. When the mist cleared, the bridge was gone. A crater where the arch had been. The far side sagged into the river, still smoking. A German truck hung suspended on its rear axles, its front buried in water. The crew stared in disbelief. The loader whispered, "That's not possible." Kessler exhaled slowly. "It is now." They logged the shot in their notebook. Charge, 2 bags. Range 3400 immediate fuse VT modified. Result, bridge destroyed. Half an hour later, their radio came alive. Headquarters demanding explanation. The other batteries hadn't fired. No one had called for a bridge strike. Yet, every observer along the valley reported the same thing. A single shell, one detonation, direct hit. The coordinates matched Kessler's sighting exactly. For the rest of the day, German engineers tried to repair the crossing under sporadic fire, but the current had taken most of the structure downstream. With that bridge gone, an entire armored regiment was trapped for 36 hours. That one shot, unauthorized, unrepeatable, delayed the German counterattack long enough for the 90th Infantry Division to secure the flank. But victory didn't feel like triumph. It felt like fear. The men cleaned the gun in silence. They didn't celebrate. They didn't report the fuse setting. They wrote standard proximity fuse in the log. Only Kessler kept the truth written in grease pencil on the inside of his helmet. Vitesse delay, 5 humidity high. Bridge collapsed. That helmet would survive the war. The bridge would not. The next morning, a captain from Division Artillery visited the site. He stared at the wreckage, then asked the obvious question, "Who fired that shot?" No one answered. In the mud and silence of Sanavo, the most precise piece of gunnery in the campaign went officially unclaimed. A miracle the Army couldn't explain, and didn't want to acknowledge, because sometimes a single perfect shot is more dangerous than a miss. It proves that the rules were wrong. The explosion at Sanal traveled faster than sound, and even faster through the chain of command. Within hours, Division Artillery had filed an incident report. Unauthorized use of proximity fuse on ground target. Resulting damage. Enemy bridge destroyed. The next line was more telling. Crew claims weather error triggered detonation. It was safer to blame the fog than admit the truth. To the Army's ordnance bureaucracy, Kessler's shot was an equation that didn't add up. VT fuses weren't supposed to behave that way. The manual said so. When math and doctrine disagreed, the manuals always won. 2 days later, investigators arrived. Clipboard men from the 3rd Ordnance Group. Faces pale and clean. Shoes still shiny. They wanted explanations in numbers. Fuse model, charge weight, angle of fire. Now, the crew stood silent while Kessler did the talking. He described the humidity, the radar delay, the arc trajectory. He mentioned the 0.0505 second offset between impact and pulse reflection. One officer frowned, jotting notes. "That's impossible," he said. "The fuse cannot sustain signal at ground reflection phase." Kessler just shrugged. "Tell that to the bridge." The captain in charge of the inquiry, a career engineer named Llewellyn, paused. He wasn't angry. He was intrigued. Paused. He wasn't angry. He was intrigued. "You're saying the radar was fooled by fog density?" "Yes, sir. Kessler said it saw the river mist as metal. I just gave it time to be sure. Technically, that was all he'd done. Tricked the fuse's logic. The VT sensor measured return strength over time. By twisting the timing ring, Kessler had extended that window, forcing the fuse to wait until it received a double echo. To the electronics, it felt like altitude. To reality, it was a bridge. Llewellyn's team tested the theory. They fired 10 rounds with Kessler's settings on a range outside Metz. 8 failed. 1 detonated early. Just one, replicated the Sanavo effect. The bridge experiment wasn't luck. It was probability. A 10% chance of success for the perfect shot under perfect humidity. That terrified the Ordnance Board. If they approved it, soldiers might start trying to copy it. And for every miracle, there'd be 9 dead crews. So they sealed the report. The summary read, "Field anomaly. Reproducibility insufficient for doctrinal review." In plain language, bury it. Kessler was reprimanded but not punished. His officers couldn't decide whether to court-martial or commend him. In the end, they did neither. The paperwork labeled the incident resolved operator error. Still, the story spread. In mess tents and gun pits, whispers traveled faster than the truth. The Esso fold shot became legend. Some said it was luck. Others swore Kessler had discovered a secret fuse mode. Crews began experimenting quietly. Halfa turn here, a shaved contact pin there. For every success, there was a warning. One battery near Saradern lost an entire crew trying to copy the setting. Another scored a perfect hit on a bunker. Doctrine called it reckless. Reality called it learning. The paradox was clear. The Army's strength was standardization. Its weakness was also standardization. The manual could guarantee safety, but never genius. Behind the silence of official reports, the engineers were listening. Within months, they began redesigning fuse circuits to include variable delay logic, programmable microscon timing that mimicked what Kessler had done by hand. The M728 combination fuse, introduced in 1945, carried both VT and impact sensors that work sequentially. Officially invented at Fort Monroe, unofficially born on Erage in France. That was how innovation survived in war. Not through permission, but through rumor, test, and replication. The bridge at Sandoval became a ghost in the files, an accident on paper, a miracle in the field, and proof that progress never asks for authorization. Kessler returned to his battery, still a sergeant, still nameless in the reports. The war moved east, but the fuse he rewired in the mud had already changed the rules. Because the math of collapse doesn't lie. When theory and experience collide, the explosion is called discovery. December 1944, Metz. The 3rd Ordnance Group convened what it called a fuse malfunction board, a polite term for interrogation. In a drafty requisition schoolhouse under flickering lights, Sergeant Walter Kessler sat across from 3 officers in clean uniforms. They were engineers, not soldiers. Their pens scratched faster than they spoke. Captain Llewellyn opened the folder marked Bridge Incident, saying St. Auld. He didn't look angry. He looked curious. "Sergeant," he said, "explain what you did with the fuse." Kessler thought for a moment. "Sir, I didn't change it. I tuned it." The major beside him sighed. "You're not a technician, Sergeant. You're not authorized to tune ordnance." Kessler nodded slowly. "Understood, sir." But the bridge didn't care about authorization. They asked for numbers. He gave them elevation, wind speed, air density. Then he mentioned the humidity coefficient, a term few line soldiers even knew existed. The proximity fuse radar doesn't like moisture. Kessler said, fog changes signal return time by a few microseconds. That's about 17 mm at flight speed. If you want to hit stone, you have to make it think the ground is farther away than it is. The youngest officer looked up. "You use the fog as camouflage for the radar return." Kessler nodded. "Yes, sir." Llewellyn leaned forward. "That's not in any manual." Kessler smiled faintly. "That's why it worked." They questioned him for hours, not as a criminal, but as a case study. The board noted that his modifications required a precision most gunners couldn't achieve under combat stress. They recorded his fuse alteration as theoretical manipulation, meaning it could be dismissed later if it embarrassed the department. But privately, Llewellyn was impressed. Hesked Kessler to draw what he'd done. The sergeant sketched the fuse head, timing ring, contact detonator, radar sensor, and the narrow band he had twisted between settings, a line no thicker than a thumbnail. The difference between an air burst and a bridge collapse. The captain studied the drawing and said quietly, "You understand you broke regulation?" Kessler nodded. "Yes, sir." "But the bridge was still there when we followed regulation." That answer went to the official record, word for word. 2 weeks later, their report was complete. The findings were contradictory, a mix of bureaucratic denial and scientific awe. Operator deviated from fuse safety protocol. Result: destruction of enemy bridge. Hypothesis: environmental anomaly contributed to unintended proximity detonation. Recommendation: no further testing until equipment refinement. In translation, don't punish him. Don't repeat him. Pretend it didn't happen. The board adjourned. Kessler went back to his unit. He never spoke of it again. But Llewellyn couldn't let it go. He sent an internal memo to Fort Monroe's Fuse Development Division describing Kessler's radar echo delay theory. Engineers there ran bench tests, confirming that under high humidity conditions, return signal lag could delay detonation by up to 0.2 Fanin. That was enough to rewrite fuse design if anyone ever admitted where the data came from. They didn't. The file was sealed, labeled classified anomalous performance. Yet traces of Kessler's influence began to appear in reports across Europe. Possible ground-triggered VT reaction. Unexpected bridge collapse following single round. Each time the explanation was the same: environmental error. In truth, the Army had stumbled on a truth it couldn't officially acknowledge, that the most important innovation of the artillery war came from a man they'd nearly court-martialed. In 1945, a new fuse prototype appeared in testing, the VTFM delay, featuring a built-in 0.5-second radar delay. The design would be credited to an ordnance engineer named Captain Dr. Llewellyn. But the math inside, the humidity correction, the timing offset, the radar echo phase, all came from a gun pit outside St. of Old. Kessler didn't know. He didn't need to. He'd already proven his point. In war, discovery doesn't belong to those who invent it first, but to those who write it down last. By early 1945, the legend of St. was spreading across Europe faster than any official report. You couldn't find it in a manual, but you could hear it in every mess tent from Belgium to the Saar. They called it the Kessler delay. Some said it was a superstition, others a secret code hidden in fuse markings. But among veteran gunners, the story had weight. A single howitzer shot had dropped a German bridge through fog thick enough to choke an engine. It was the kind of story soldiers tell because they want it to be true. At first, it was just rumor. Then it became field doctrine, unofficial, whispered, dangerous. Battery D of the 174th Artillery near Sarlau was the first to try it. February 1945, the target, a fortified warehouse used by German artillery spotters. 3 shells fired, 2 airbursts. The third, set with what the gunner called a Kessler twist, hit low and detonated inside the structure. The roof lifted, the walls folded. Instant kill. The after-action report simply read, "Observed anomaly in VT detonation. Observed anomaly in VT detonation. Effective." 2 weeks later at Bitburg, another crew attempted the same trick. Their fuse detonated 40 yards from the muzzle. The gun disappeared. 6 men died. That's how word spread, dear. Not just through success, but through blood. The men began calling the trick the coin toss. Heads, you erased a bridge. Tails, you erased yourself. Commanders couldn't stop it. They didn't even know how to identify it. The Kessler delay required only a tiny, unauthorized twist, invisible to inspection, undetectable in the field. By March, ordnance investigators noted a rise in unexplainable ground-level detonations in fog or humidity exceeding 85%. The report stopped short of blaming sabotage. Instead, it used a new phrase, field-initiated calibration variance. That was bureaucratic code for someone's doing something clever we can't officially approve. Meanwhile, across the Rhine, German troops were learning to fear American artillery all over again. They called it naval blitz, fog lightning. Shells that shouldn't have hit were finding their mark through smoke, rain, and mist. Bridges vanished, convoys stalled, rail junctions cratered without warning. To them, it looked like precision technology. To the Americans, it was unrepeatable magic. But Themath said otherwise. The proximity fuse's radar reflection range at high humidity was variable by plus 20 degrees. Exactly the window Kessler had exploited. Once a human realized how to manipulate that range, the impossible became statistical invitability. In some sectors, the kill rate of American artillery jumped by 15% in fog conditions. A silent data point no one dared connect to the rumors. Even in headquarters, the whispers grew. An engineer in England wrote in his logbook, "Some crews are operating their VT shells in mixed mode, both proximity and contact. This behavior cannot be explained by design." He was right. It couldn't. It had been discovered, not invented. After the war, historians combing through captured German reports found dozens of references to new American fuse sightings, bridges, bunkers, and trains hit by single rounds. The Germans believed it was a secret radar-guided artillery round, a technology 20 years ahead of its time. It wasn't. It was the same fuse, just fired by men who ignored the safety instructions. One British liaison officer called it mechanical heresy. Another called it combat intuition. Both were right. By April 1945, even as the war neared its end, the U.S. Army quietly adjusted fuse production, strengthening proximity heads to survive impact detonation. No public admission, no acknowledgement, but on the assembly lines, tolerance settings changed by thousandth of an inch, enough to handle field variants. That wasn't evolution. It was adaptation under silence. The Kessler delay lived on, not as a method, but as a mindset. The idea that the battlefield had its own physics separate from the manuals. And like all good myths born of necessity, it spread faster than truth because it worked. Sometimes the war would end, but the legend of the gunner who erased a bridge would keep traveling down the line. Every time a crew questioned a setting and wondered, what if we twist it one more notch? In that question, innovation survived. Because every weapon has a manual, but not every soldier reads it as law. When the war ended in May 1945, Sergeant Walter Kessler went home with no medals, no commendations, and no mention in any report. His service record was clean but ordinary. Operated heavy artillery in European theater, 1944-45. Nothing about the bridge, nothing about the fuse. History survived only in the gaps, the things the paperwork didn't say. For the Army, his innovation was a problem. Nota triumph. You couldn't celebrate an act that broke every fused safety rule ever written. You couldn't decorate a man for proving that doctrine could fail. But inside the ordnance laboratories, Kessler's ghost lingered. Engineers at Fort Monroe and Picatinny Arsenal began redesigning fuse circuits, quietly borrowing the timing logic from the St. AOL anomaly. They called it variable delay sequencing, the same principle that Kessler had discovered by instinct. By 1946, a new standard fuse appeared, the M728 combination variable delay. It was designed to trigger either on radar proximity, surface impact, or both depending on a new microscon scale delay. It was safer, more stable, and quietly based on everything the band trick had proven possible. The engineers who patented it never knew Kessler's name. Or maybe they did and left it out on purpose. Some legends work better without signatures. For Kessler, the war faded into civilian life. He became a machinist in Ohio, spent 30 years cutting gears and teaching apprentices. The only clue to his past sat on a shelf in his workshop. A rusted fuse, head cracked from handling, with a tiny hand-carved mark scratched into the metal. VT0. When asked by his grandson years later what it meant, he only said, "That was the day math told me I was right." He never mentioned the investigation, never mentioned the bridge, but his name appeared once decades later in a declassified ordnance memorandum. A footnote. Field observation by Sergeant W. Kessler, 379th EFA, provided empirical basis for future fuse timing development. One line, that was it. And yet that one line marked a shift bigger than any decoration. It meant the military had learned something it rarely admits. That the field, not the lab, defines progress. The Band Zero delay twist had forced the Army to face a paradox that safety and innovation are enemies on the battlefield. If you wait for permission, you're too late. That's the cost of genius. The system can't reward it, because the system exists to prevent it. But history does. Every modern artillery fuse from the Korean War to Iraq traces its lineage back to that forbidden principle. Proximity plus contact, delay by microseconds, detonation by certainty. 100 engineers perfected it. One gunner proved it first. In the end, Kessler's story wasn't about defiance. It was about clarity. seeing physics where others saw rules. He didn't gamble, he calculated. And for 1 second on a fog-drenched ridge in France, he outperformed every engineer, every officer, every manual in the U.S. Army. The bridge at SV was rebuilt years later. Drivers cross it daily, unaware that its destruction once redrew the boundaries between discipline and imagination. That's the quiet irony of war. The men who change it the most are the ones no one remembers. But every time an artillery shell arcs over a modern battlefield and detonates exactly where it should, it carries a trace of that heresy, a fraction of a second borrowed from a man who believed that rules were just slower forms of math. Because in the end, the future doesn't belong to those who follow the manual. It belongs to those who rewrite it under fire. There are victories that make headlines, and then there are victories that remain classified, sealed inside notebooks, test reports, and the memory of one man who refused to stop thinking. The destruction of the S of all bridge was one of those. It didn't change the course of the war, but it changed how the war thought. In an army built on procedure, one soldier proved that obedience and intelligence don't always coexist. He didn't rage against the rules. He simply noticed where they didn't fit the data. His weapon wasn't rebellion. It was precision. War doesn't reward men like Walter Kessler. It uses them quietly, then forgets them. His fuse trick, the zero delay twist, was never officially recognized, but its fingerprints are everywhere. In every artillery shell that adjusts for air density, in every smart fuse that waits for the perfect echo before striking. What he discovered under fog and pressure wasn't just a technical glitch. It was the truth that every battlefield eventually learns. No machine, no manual, and no order is immune to reality. The radar didn't know it was illegal to think. The fuse didn't care about doctrine. They simply responded to the world as it was, wet, dense, imperfect. Kessler followed that reasoning wherever it led, and the world replied with a sound that erased a bridge. He demonstrated without words or ceremony that progress is always perilous, that precision can resemble defiance, that a single man with a wrench and an idea can bend the laws of physics before the rules of command can catch up. The army would move forward. The fuse would advance. The manuals would grow thicker. But the real lesson remained hidden between their lines. That innovation, the kind that changes wars, never waits for permission. Kessler died in 1972, unnoticed, his name missing from every commendation. Yet his idea endured. Every modern proximity fuse that merges timing, radar, and delay carries a trace of that moment. The instant a soldier trusted calculation more than authority. No one saw him as a rebel. He wasn't. He was a craftsman solving a problem under fire. The kind of man who kept the machinery of war running not through orders, but through understanding. That's what separates destruction from mastery. Knowledge. He didn't destroy the bridge from anger or pride. He did it because he saw in the moisture and the numbers that perfection isn't safety. It's alignment. And that single alignment, for one fleeting second in 1944, was enough to alter the future of artillery forever. Because the true power of war isn't found in the size of a weapon or the number of shells fired. It lies in the mind that refuses to accept the impossible. That's what Kessler proved on that ridge in France. He didn't just fire a shell, he fired a question. One that every engineer, every commander, and every soldier still has to answer. Do you obey the rule that keeps you safe, or the math that makes you right? You safe, or the math that makes you right?